we're here about. My name is Thorsten. I work as a consultant at ThinkFactor here in Germany. Mainly I focus on cloud native application development. That means obvious things like Docker and Kubernetes and stuff like that, mostly targeting Azure as platform. And of course, infrastructure as code. And perhaps you recognized right before the meetup, Damian and I talked a little bit about different providers or solutions that are available in the infrastructure as code space. So my focus is Terraform. I know about the competitors like Ansible and Pulumi. They are all valuable. They have all their spot, but I fell in love with Terraform because of several features or unique selling points, however you may name it. And the idea is to give you to provide a common understanding of infrastructure as code, Terraform, then share those benefits from my point of view. And then we go over to a bigger demonstration, which is the main part of this meeting. Most important thing on this slide, of course, is the email address. So if you have any kind of question, don't hesitate, just ask or shoot me a line on Twitter. I think that's enough about myself. So talking points. I separated the talk into 4 main areas. So first, it's the introduction stuff. Then there's the big demo part where we focus on how to do the first, let's say, Azure infrastructure using Terraform. Then I have a quick example how to integrate Terraform in a continuous integration workflow based on GitHub Actions. And for this, it's almost the same as for Azure. It's just one example. You can, of course, use Terraform with AWS, with GCP, or with different cloud vendors or on-premise infrastructure vendors. And for the continuous integration part, GitHub Actions is the sample I choose. There's, of course, a seamless integration in Azure DevOps, in Jenkins, and all others. So please don't blame me because of choosing GitHub Actions here. It works in Azure DevOps seamlessly. Last but not least, I have compiled some resources, free resources. I referenced, I think there's one paper book, so a classic book also mentioned in that list. So if you want to dive deeper into Terraform, that's just a collection of a few sources. And you don't have to write down all the links in that that are shown in the presentation or the URL for the repository. I think, Damia, can we publish the slide deck and or do you have mail addresses from everyone so we can reach out afterwards?
We will publish that in our Azure Meetup portal and provide URL where the people can download that. So if you have, I guess you have some Git space where you are anyhow going to put it there, send me URL and we will post that in
okay, cool. So
okay,
that's nice. So Damia will publish the link to the sample, and I will also include the slide deck so everyone can run through it afterwards if you want to. Okay, one important thing I have to mention that I almost forgot. We have 2 kids here at home, and like everybody, I'm sitting in the home office, and it's almost time for them to go sleep because they wake up in these days around about 5 a.m. So maybe you hear some girls crying or screaming in a couple of minutes or in an hour or so. So please forgive me. We are all in the same boat currently, so that may happen. But my wife tries to do her best.
This is no problem. Maybe some of attendees will have the same problem. So it's everything fine. Okay.
Yeah. Okay, so let's give it a spin. What is Terraform? First of all, Terraform is a product or a tool created by a company called HashiCorp. And it is one toolset in the infrastructure as code space. It's written in Go. That's just a small side note. Like almost everything in cloud space these days is written in Golang. But it means it's a self-contained executable that's available for a broad variety of operating systems. And that's important if you think about all those different continuous integration systems that you may find out there in the wild or that may exist in different organizations. So Terraform is just a single binary that you can download, and you don't have to run through any kind of installation process. There's no server-side component involved, nothing. It's just a CLI that you install, and then you can run Terraform projects. That's quite nice. It's an open source tool, so the Terraform CLI is open source. And on top of that, HashiCorp has their way to monetize by adding dedicated features in paid, sitting behind a license fee. So there's Terraform Cloud, which adds a bunch of collaboration features. And there's Terraform Enterprise, which adds, again, governance features on the top of those infrastructure as code projects. Everything that we will talk about today is targeting the open source version of Terraform. And that's also what we use in real world projects. We address several collaboration features by relying on regular things like GitHub pull request or Git pull request workflows and review features that are provided in systems like GitHub or like Azure DevOps. So there's, let's say there's a bunch of collaboration features could also be consumed by using tag that you already have in your organization. But yeah, if you want to get a little bit more and a little bit fancier and more integrated collaboration features, then perhaps it's worth checking out those paid offerings from HashiCorp. Okay, so if we think about, or if you're new to Terraform, there's one slogan that Terraform tries to spread around the world, and that's write, plan, create. And those three verbs are great to explain and to get started with Terraform. First, write. So the write verb is all about adopting infrastructure as code. To go from a perhaps manual or semi-manual process of creating, managing, or modifying infrastructures to a more automated way. Terraform has a couple of, or the idea is to that you see those stages as a continuum, and you try to move from manual towards fully automated. And fully, by saying fully automated, I mean you have your infrastructure expressed in code at some point in time, and then you just hit a button, or by pushing the code somewhere, a new infrastructure may be created without any manual interaction, or an existing infrastructure may be modified to match your new requirements or your new desired state. So that's everything in that write, or what is behind that write verb. Second, there's plan. And plan is, from my point of view, the biggest unique selling point offered by Terraform. What Terraform does, it looks at all the different infrastructure vendors or cloud vendors that you use in your project, and it will explain, or it will give you a detailed plan of what happens when you execute a Terraform script. And that's a real benefit if you compare it to things like Azure's naked ARM API, let's say that way. So the API that backs the Azure portal, that backs the Azure CLI or the PowerShell commandlets. And the third one is create, and that's all about creating reproducible infrastructure so that you just have your project written once and you spin up like thousands of infrastructures that are all the same but run in different subscriptions or have different domain names or have slightly different configuration. Like, for example, you have all your data is stored in a SQL server, and in development, you may want to use a cheaper version of that SQL server offering, like SQL Azure. Whereas in production, you want a full-blown, pretty expensive edition of SQL Server because you want to have that computing power. So that's all about create. I've also written down a little bit more in detail what those verbs mean. So for write, the overall idea of infrastructure as code is, sorry? Was a question, or was that just a unscheduled interruption?
Just proceed, Thorsten. So we will answer question at the end, yeah?
Okay, cool. Okay, so the overall idea of infrastructure as code is just to have a better documentation about your infrastructure, to have a representation in code that everybody on the project knows where it is and what makes your infrastructure. So all the components, no matter if it is a SQL server or if it is a web server or some PaaS offering or is a software as a service offering, all those things will come together into one project, into one Terraform project. And that makes things visible, and then you're able to eliminate the truck factor. That's how I called it here in the slides. So I found many projects where there is either a dedicated division, or there's that one guy who's responsible for managing all the Azure stuff or all the AWS stuff because he knows best. And what happens if you run into issues or if you have to spin up a new environment while that guy is on vacation or while he's sick or while he's just on another project? So this is something you have to eliminate also from risk management perspective, because it's a single point of failure. And if the infrastructure is also shared knowledge and is expressed in code at in some place, like I put here a Git repository as an example, then you can go through the history. You can see how your infrastructure evolves over time. And perhaps at some point you had to scale up or scale in the database. And a couple of days after scaling out or in, you recognize that some operations were failing. So it's easier to spot why things or bad things happen if they happen. And additionally, you can start collaborating on your infrastructure and the mutations of your infrastructure. That's typically done by pull request workflows, including reviews and stuff like that, if you think about that transition to a Git repository again. And having that or comparing it or explaining it in the area of Git also helps you with the next one, with plan, because previewing changes in Terraform, you can just think about Git status, right? You have your code repository or any kind of files, you do some changes locally, and before pushing those changes or distributing them to your coworkers or your teammates, you do a Git status, and then you see, okay, you have added one file, you have modified those 3 files, and you can drill deeper. You can say, hey, you modified in the second file, the 3rd paragraph. And in contrast to that, you have deleted another file. So that's what Git status gives you as a developer, and the Terraform execution plan gives you exactly the same. So you have some kind of infrastructure already deployed somewhere, and you do a Terraform plan, and the Terraform plan gives you a detailed execution plan that says, if you execute this project right now against that credentials, then I will spin up a SQL server because that's missing in the destination environment. I will modify your app service or your web server, and I will delete that instance of application insights because you moved away to another software as a service offering. And that's a benefit. And that's a huge benefit. You see everything before any change will be done in your cloud infrastructure. So that's plan and reproducible. As I already mentioned, you have one Terraform project or script that depends on the size, let's say it that way. So one script or one project that can be applied a million times. Think about having a big development team. Every developer needs a dedicated environment. Then you just execute the script. You can use variables, string interpolation, built-in functions, stuff like that to, for example, ensure unique domain names or several identifiers that has to be unique in cloud worlds. So that's easy to achieve. A different scenario is if you do a multi-tenancy application where the model or your business model is that your customers are so big that they bring their own cloud subscription. You can just say, okay, give me a service principal in the Azure to stay in the Azure context. Give me a service principal, give me a subscription ID, give me a tenant ID, and then you're good to go. You set those values and you execute the script, and your customer is up and running in a few minutes or seconds, depending on how big your infrastructure is. So that's what Terraform is all about. It's all about those three main pillars, and every infrastructure in Terraform has a simple but yet powerful life cycle that it went through. So at the starting point, we always write some code, right? So we have to express our infrastructure in some kind of code. Which code that is, we will talk about on the next slide, but take it as you have to write some code. Then you execute Terraform plan, just a sub command offered by the CLI that gives you that execution plan that looks at your Azure subscription and says, okay, I have to spin up this or I have to modify that. You verify that. You say, okay, that looks good. I want to have that up and running in my Azure subscription. Once it's verified, you execute Terraform apply. And maybe if someone in the audience already knows Terraform, then I can foresee already a raising hand who says apply is currently, or since I think 6 or 7 months or so, HashiCorp changed things a little bit. So there's a dedicated plan command and there's apply. Apply will write changes to the infrastructure. But apply also executes plan internally to prevent you from misconfiguring or accidentally modifying an existing infrastructure. So, but we will get there. No worries. So you execute Terraform apply. Terraform will go talk to the APIs of the cloud vendor, spin up the resources, and once everything is up and running and matches your project or your script, then you can consume the infrastructure. And then the cycle begins at the very beginning, because then you have some new features that you have to implement. You need another service, you write some code, you plan it, you verify the changes, you apply those, they get deployed, you consume them. Depending on which infrastructures or which projects you're facing, or if you spin up development environments, you may hit that point in time where you don't need the infrastructure anymore. Then you can also execute Terraform destroy. Come on. There should be a, okay. That was my PowerPoint lagged a little bit. So there's Terraform destroy. At some point in time, you may execute Terraform destroy to delete all the infrastructure. Normally, or quite often, I get the question at that point in time, can I prevent Terraform from destroying in previously created infrastructure? Yes, you can. So there is a dedicated attribute that you can set on all your, or on the entire project, or on different aspects of your project, and says this one may not be deleted anymore. So someone has to go into Azure and has to delete it manually. that's also possible. Okay, write code was the first thing, or that's why we're here about how to write infrastructure as code in Terraform. So HashiCorp decided to create its own language to express infrastructures. And that's called the HashiCorp configuration language, and that's HCL, that's the acronym for it. So it's a declarative language. That means that you write down the desired state of your infrastructure, and in contrast to other infrastructure as code offerings or products or tools that are available in the wild, that's a benefit from my point of view, because there's no imperative, there's no control loop or thing happening at runtime that may result in a different or in a different or in a dynamic infrastructure. It's the infrastructure, it will always represent what you described in your HCL, so in your Terraform project. The language itself is based on JSON, so that means it's quite easy to read. HashiCorp itself removed a bunch of plumbing from JSON to make it smaller, more focused, and a little bit more convenient and even more readable. And that's the second benefit compared to other tools. So you don't have to know a higher order language such as C# or TypeScript inside out to do infrastructure as code. So if you have a team with developers and IT pros, perhaps testers on it, QA people, also QA people are able to read and contribute to the infrastructure if they have to. Where in contrast, if you have to express it in C# and your, I don't know, lead developer starts, spiking your infrastructure, then you might end up in interfaces, dependency injection, and all that stuff that's added by language and by the frameworks underneath the, sitting on top of the language. So maybe it's an advantage to keep things simple. Yes, it's a different language that you have to use, but it's a simple one. Yeah, it also comes with a simple type system, so only a handful of types that you use throughout your scripts to express everything. And obviously, you just have to learn that one language, and it doesn't matter if you talk about automating infrastructures in Azure, in Amazon AWS, in GCP, or if you use kind of on-premise infrastructure with VMware. There are tons of providers that you can bring into your project and use that one programming language to stamp out your infrastructure. Okay, so that was the boring part. But before we jump into Visual Studio Code, let me quickly go to my browser. So you should right now see that's the Terraform landing page. And to give you just an idea of what's possible. So there are so-called providers. So Terraform itself is stupid. There are those providers that add real value to Terraform CLI. And each of those providers talks to the dedicated API offered by that company or by that service. So for example, there's a Azure provider that we will use that talks to the Azure Resource Management API underneath the hood to automate things in Azure. There's AWS that uses AWS API and so on and so forth. So that's major cloud. And if you go to, if we just go to the top level landing page, you can see there are a bunch of providers where you can choose from and add into your project. So chances are good that you find the provider you're looking for. And obviously you can create your own providers if you have that amount of manpower available. So it's not limited to things like Azure, AWS, or VMware or 1&1 or Hetzner, to name just a few. You can also spin up GitHub repositories, for example, like there is a sample over here, how to spin up a GitHub repository, in that case, a private one. So a lot of possibilities, and you always use one language to talk to different platforms or targets. So we will target on major cloud Azure today. And I have already started my Azure portal. So we are looking at our development subscription. There are a bunch of resource groups already there. And as part of the demonstration, we will spin up several resource groups with some resources with the name Terraform in it. So to be a little bit more focused, I will stick with this filter right here. And let's get started, right? So we have an empty folder over here. Let's bring up the console in the Terraform webinar FFM folder. So there's just an empty README. Like always, I have to add a TBD for the README. So first of all, what is a Terraform project? A Terraform project is nothing else than a folder, right? Every folder is a Terraform project. And to make things a little bit more flexible, every Terraform project is also a so-called module. And modules are great if you have bigger infrastructures or if you work in a bigger organization. Module is that unit or that shareable unit in Terraform. So you can, for example, consume existing modules from a centralized registry. So like a NuGet, like a NPM, like a Docker Hub. There's also a registry for Terraform modules. And there are also a bunch of official Microsoft modules already available. So for example, if you want an Azure Kubernetes service full-fledged with all the flexibility to fine-tune all those attributes, then you can either do it or script it manually using Terraform, or you consume the official module and just configure that one. So that's a nice way that you can start small and simple and then distribute those small, simple projects or modules throughout your organization. And that's how the idea is for this demo. So we will start with a slightly simple infrastructure that has, first we have a resource group. In that resource group, we will end up with an instance of application insights to have something. Then we have an app service plan that will be a Linux one. And we have an app service that runs a Docker image from Docker Hub. So that's the infrastructure. We start small. So we start with the resource group. We will learn the building blocks in Terraform, and then we will add more resources, and then we will deploy it. And we have our single infrastructure in the cloud. And then we will take this infrastructure and say, okay, we turn the project into a module. Let's do that. Turn project into module. And then we will spin up development environment and lazy one, staging environment, oops, and production environment with slightly different configurations. It's just to show you how to get started, how to adopt it, and that you get a feeling of how simple Terraform is to come up with more complex infrastructures. So that's the idea how the demo should work in the next I don't know, half an hour or so. But yeah, to get started. So we have an empty project over here, and you need, obviously, you need a kind of git ignore, because we will say git init over here. So there's a Git repository right now. And in Terraform, we have to exclude several files from the repository. And there is GitHub, if you don't know it, GitHub/gitignore. That's a great repository where you can find typically or popular gitignore files. And if you wonder which extension I use here, that's Octotree. That's, I think, the best extension ever. It's a free, I use the free version, and that allows you to jump through repositories. Oh, Fortran, no, we don't do Fortran. We do Terraform today. So you can quickly jump to files, open the raw mode and stuff like that. So we'll take this gitignore file. I have a wget that downloads that gitignore and renames it. So we have it like we need it right now in the project scope. Okay, let's turn the terminal a little bit down for now. In a Terraform project, all files with the extension .tf will be taken into consideration if we use Terraform CLI. So I always start simple and then try to find or try to establish a scalable, let's say, way of how to organize resources and files in that project. So no matter how many .tf files you create, they will all be taken into consideration, and Terraform will build up one big file before applying or looking at it. So I start with the main file. That's where our resource group will go to. That's where our application insights instance will go to, and so on and so forth. But first we have to instruct Terraform that this project will or has to talk to Azure. So we have to install that provider, and the provider and other common configuration things I always tend to put in a file called meta.tf. And the provider is the first top level building block that's commonly used in Terraform. So we have to address it by its name, Azure RM for resource manager. And we have to say we want to use the default features. Let's go to the terminal here. That's it. So now we have instructed, or we said, okay, this project has to work with the Azure provider. But up until now, nothing happened. So if you start a new Terraform project, so I have Terraform already in my path, I've downloaded it and just put it somewhere and linked it so that I can execute it from everywhere. So the first thing that you execute in the scope of your project is Terraform init. And this looks at all the TF files and tries to find plugins. That's a way how to extend Terraform by providing custom Go code that will be hooked up in the pipeline. And it looks if there are some providers. And it recognizes, hey, I found Azure Resource Manager provider and I'm downloading version 2.6.0 and install it in the scope of the project. Okay, that's fine. So that's right now here somewhere in the .terraform folder, which is ignored. So that won't make its way into source control. That's just there for local execution right now. Okay, so having the provider set, we can focus on creating things. In Terraform, everything that you create, write, or manipulate, it's called a resource. So there's a top level building block called resource that needs at least two attributes. First, it needs a type, and then it needs a name, a unique name, which is used to reference it throughout the script. So we want to create a resource group, Azure RM _. Let me bring up the IntelliSense in code, resource group. Yep, that's okay. And then let's give it a name. That's the webinar RG. No, let's do it the other way, RG webinar. Naming things is hard, right, isn't it? Okay, let's call it webinar. And as you can see, I got some curly lines here that says, hey, you miss 2 required properties or arguments. You have to set a name and you have to set a location. Okay, makes sense. Name, we call it RG webinar, let's say development. And for location, let's set West Europe. And as you can see, there are different attributes that you can set. Let's, for example, I always consult people to set tags on Azure resources, because then it's easier to navigate and to filter in the Azure portal. So the app right now is the Terraform webinar or meetup. Sorry, let's say it. Come on, let's do it like that. Azure meetup. Let's call it virtual meetup. And there's an equal sign missing, and responsible am I for that one, because I deployed to our corporate Azure subscription to save my credit card. So I have to put a responsible tag there so that everybody knows, okay, this resource group belongs to Thorsten, and if I need something or if something has to be changed, then the one will come over and talk to me. Okay, so we have a simple infrastructure right now. I mean, it's still useless because it's just a resource group, but that's a great way how to learn the Terraform lifecycle. So let's do a Terraform plan. And if you remember, Terraform plan will look into the cloud and it will try to identify what has to be done that the cloud matches my described state. And it takes a couple of seconds, and then it says, you can see in the summary, plan 1 to add, 0 to change, 0 to destroy. And you will see I will create a resource group, and the ID is not yet known because it's non-existing. It will end up in having this name and these tags, and it will be located in West Europe. That's great. But maybe you ask, okay, you've just specified the Azure provider. You don't have set any kind of credentials. How is the thing authenticated against Azure, and why does it know, or how does it know which subscription it has to deploy to? So Terraform Azure provider gives you 3 ways of how to authenticate against Azure's APIs. First, and that's what I'm using here, it's reusing the Azure CLI authentication token, and it's using the Azure subscription and the Azure tenant that's currently configured as your enabled subscription. So that's really, really cool and seamlessly for development machines, but it's not great in an unintended world when your script runs on your CI/CD system, or when you have, I don't know, just a recurring task that just kicks off Terraform. So there are 2 other ways how you can do it. You can do it using a service principal that you have pre-provisioned or that your IT guy hands you over. So then you need the service principal ID and the password, or the service principal ID and the certificate. That's the second way how you can authenticate against Azure. The third way, if you, for example, execute your Terraform script on an Azure virtual machine, you can assign a managed service identity to that virtual machine, and then you can reuse that managed service identity from within Terraform. So there are 3 different ways how you can authenticate. From the projects I'm typically facing, you have normally you get a service principal that you can use to talk to a dedicated subscription, or where you have contribute rights into a dedicated resource group. Then that's okay to spin up or to authenticate. How that's done, we will see that later because I use that stack of authentication in GitHub Actions. So it's just easiest setting a couple of predefined or a couple of environment variables instead of hard coding it and having the potential risk to leak a kind of identity in the source code repository. Okay, so we have planned, and we saw that a plan looks Terraform plan, the execution plan looked quite good. So we verified, let's say we verified it, and yes, we want to have that mission critical resource group in our Azure subscription. So we execute Terraform apply. Terraform apply, as I mentioned, since a couple of months ago, they will also split out the Terraform execution plan. We have to approve it. Yes, that looks great. Please spin that thing up for me. And now it talks to the Azure ARM APIs, and we will see in a minute creating, and there we go. We should find a new resource group over here in Azure. I called it Azure, right? I called it Azure. Come on, takes a second until the ARGI webinar. Okay, webinar. Sorry. There we are. We called the app. The tag was Azure Virtual Meetup, and responsible. There is the second tag that I specified. So we just end up in having a regular Azure resource over here. That's great, but let's destroy it. And for destroy and auto approve, destroy and apply, you can also say auto approve. And you won't be asked if you are sure that you want to execute that. So in that case, it will just call to the ARM APIs and say, hey, please delete that resource group. And we should see that being destroyed in a second. Come on. It's heavily depending on the provisioning speed of Azure. So the portal still thinks it's there. Still destroying. Yeah, take some time to delete critical resources. We will take care about that later. So while Azure still is deleting that empty resource group, now it's deleted, we can look at several things here. I hard-coded by intention name, location, and tags. And that's something you don't want to do in real-world scenarios, just so you can use another top-level thing that's called variables. Let's bring in some variables first. So obviously the location. Location is a type of string. String has a description, or the location has a description as an Azure location for all our resources. And we can provide a default value of West Europe. Okay, so let's refactor our script to use variable var.location instead of the hard-coded string. Then we have development over here, and at some point in time we want to spin up multiple environments. So we have to use string interpolation at some point. So we have to replace development by another variable. And let's say variable environment name type equals, again, a string. We get rid of the description already, and we say the default value is development. And then we can bring in string interpolation here by saying $ curly brackets, and then we say var.environment name. So now our script is slightly more dynamic. and is a little bit more flexible. Last but not least, we have those tags. And we want to be able that at runtime, you may, for example, decide to add a mission critical tag to your entire project or to your infrastructure. So you say there's a variable called tags. That's a type called in Terraform map. And it has a default value of an empty map. If someone or if the user doesn't specify tags at runtime, we want to use our default values over here. And we can achieve that by using built-in functions, like, for example, the merge function. So we can, for example, say merge our default tags and with a higher priority, take all tags from the input variable. So that's great. But if we keep it like it is right now, then we have to reference the tags all from the resource group. So Terraform, let me bring that down a bit, knows the concept of local variables. Local variables can be modified in that locals block. They can't be set from the outside. Where in contrast, environment name could be set, for example, by adding an argument to Terraform apply or to Terraform plan, or by setting an environment variable. So there are different ways how you can manipulate variables in Terraform, but local variables are immutable. So let's say there are default tags. There are our default tags, right? Those two. And then we want to end up with all tags, which is just the merge of local.default tags and variables dot the other tags. So the custom tags, let's say it that way. And then you can set on your resources tags equals local dot all tags. Having those simple mechanisms allows us to, for example, say, if the user doesn't specify the responsible person, my name will be set. If, however, at execution time, I set a responsible tag saying John Smith, then it will override the defaults. So it gives you a bit of flexibility and control in your infrastructure project. Okay, so we get rid of all those most of the hard-coded values for our resource group. So it's time to add more resources right now. Let's add some application, Azure RM. Perhaps I need to make it happy. Oh no, the IntelliSense crashed. Let me quickly Azure RM. Yeah, it happens from time to time if you are living on the edge and using latest and greatest extensions, but that's fine. Application Insights, that's how it's called, and we call it AI for Application Insights. Well, let's call it Insights, like this. Okay, Application Insights also, I have to double check, needs some metadata like a name, obviously. I prefix Azure resources always with an identifier. Webinar. The name of an Application Insights instance doesn't have to be unique across the border of the resource group. So AI webinar is fine. But it makes sense to have it unique for navigation in Azure portal, right? So let's keep it with that. Then we have to specify to which resource group this application instance has to go to. And then we can, instead of using that string interpolation again, we can access or reference the existing webinar resource group and can say that's the name of the resource group. And the same applies for the location, because Application Insights also is a targeted Azure resource for example, Azure Front Door is a global resource. But if you're not focusing global resources, then you have to specify the location. And again, we're saying Azure RM resource group, reference our resource group by its name, and pull the location from there. Then we have tags that we set to local.all tags. And we have one application insights specific property that's called application type, where we can instruct or provide Azure a bit more information and say, okay, we are currently, or we want to use application insights in the scope of a web app or web API, some web-ish thing that exposes HTTP. So we call that one as an application type web. Okay, now we have two resources and a bunch of variables. Let me quickly execute Terraform plan. Come on, Terraform plan. And if my script is valid, then we should see execution plan that wants to add two resources, the resource group and the application insights thing. Okay, application insights is reusing properties from the resource group. So it's a dependency, right? We can, I mean, for the resource group, it's obvious, but we can deploy application insights at that point when the resource group has been deployed, because we reference it over here by name. Over here, we say we want that name or we want that location. And you may reference a property that's not known up until that point that the other resource has been deployed. So Terraform builds up a dependency tree automatically. So it goes through all your infrastructure and builds up a huge tree, and it tries to execute as many deployments, resource deployments in parallel as possible. So later on, we will add an app service plan. And in that app service plan, we will add an app service. And that app service will also use the resource group properties, the application insights properties, and the app service plan properties. So Terraform ends up and knows, okay, I have to spin up the resource group, then I can in parallel deploy the app service plan and the application insights instance. And at last stage, I can spin up the app service. And that's all done automatically behind the scenes. However, if you have to, you can explicitly list dependencies by specifying depends on a resource. So Terraform adds a bunch of each resource. It's important to know. Let's go there. In the provider has its own schema and has its own properties. So let's, for example, take a container registry that has a fairly simple one, right? So you have a full automatically generated documentation based on Azure's API. And so you see, okay, I can set the following values, or perhaps SKU. We all know that that's the combo box that puts pressure on your credit card, right? So you also see which are valid values if it is represented by a combo box or a checkbox or something else in Azure Portal. So there's documentation for everything. On top of those resource-specific attributes or properties, Terraform adds a bunch of common properties, and depends on is one of them. So you can explicitly say my application insights instance depends on a SQL Server instance, whatever, doesn't matter. Key point is, if you want to explicitly set a dependency, you can do so. Okay, so that's the application insights instance, but let's move on. Can I reload this one? Reload window. No, isn't there a shortcut for that? No, I don't think so. Let me quickly reload to get back into IntelliSense. Oh, God. Can't recall the shortcut for reloading, including the extensions. Your installation appears to be corrupt. Great. Things that you don't want to see in a demo, right? Okay, but now IntelliSense looks a little bit better. What do we have? We want to add another resource, and let's call it Azure RM. There we go. App Service Plan. That's our web app plan. And we can start copying things because we need most Azure resources share some common properties like name, which resource group does it belong to, the location, and the tag. So let's say that's ASP webinar, including environment name. The resource group obviously is pulled from our webinar resource group over here, and location, it should also be in the same location to reduce latency. And we will end up having the same tags, but we have some resource-specific properties that we want to and have to set, like, for example, the kind that specifies if it is Linux or if it is Windows. We want to use Linux for now. We can say it's please use a reserved app service plan. No, true. That's what I want to set over here. And we have to set the SKUs, so we have to specify how many money we will pay or which features do we want to use in that app service plan. So there's a tier where you can put free, basic, standard, premium, let's say standard, and there's a size, let's say S1. Okay, there are a bunch of other properties that you can set, ISK Xenon, and so on and so forth. Yeah, that's just depending on your needs. You have to find the right properties matching the checkboxes in Azure Portal, right? So that's the web service or the app service plan. And last, we want to bring up the Azure RM app service. Where's the app service? There is the app service. That's the web app. So the web app shares also those. And this one, okay, that's app service, not app service plan. But we need to set the app service plan ID, and this one we can query from the app service plan with the name web app plan, and there we get an ID. That's assigned by Azure once the resource is provisioned. Okay, app service has a bunch of settings that we can set. We can, for example, let me bring up this a little bit more to the top, that's easier to read. Okay, for example, we can say we want a managed service identity to be assigned by Azure. Type equals system assigned. That's it. Those 3 lines instruct Azure to spin up a managed service identity and run the app service in that security context. We want to specify some app settings. For app settings, we want to set app insights instru. Oops, I have 2 cursors. That's not so good. Oh, I have 2 cursors. Okay, messed it up. Let's make it. I had 2 cursors for quite some time. Nobody said something. Okay. Okay, there we go. So I want to set app insights instrumentation key. That's the magical name of the environment variable to use the application insights SDK without pulling the instrumentation key manually at development time from some property. And we want to use the instrumentation key that will be assigned to our resource at some point in time, meaning if or when Azure has provisioned that one. So we say Azure RM in application insights. We called it insights, and there is a instrumentation key. My IntelliSense is not working all the time because I've enabled some experimental language server feature thing. So that's a local thing. Normally you get a little bit better IntelliSense. You're also able to command click or control click on the type. And then you will end up in the corresponding documentation over here. So that's normally, or you will end up in finding a better experience than I have right now on my machine. So let me quickly show you application insights. And there's an attribute, a reference, and you see besides all the default values, there's exported the instrumentation key. And that's the one we want to read and menu and then set on the app setting so that the app service is able to immediately talk to application insights. Okay. Another thing is missing. We want to deploy a Docker image into that app service. So there's site config that can be used to enable, for example, always on, so that the web app doesn't go asleep if there's no request happening for an hour or so. Normally Azure puts that web app in asleep, and then there is a thumb zoning, so they wake it up on the first request again, and it takes there's a cold start, so that means, or semi-cold start, it means it takes some time. So you can disable that by say, hey, this one is always on. And then you can, for example, say, also if you're doing Node.js, .NET Core, PHP, Python, whatever, you can set the framework version that you want to use on Linux to magical word like, I don't know, Node.js, blah, 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 something, or .NET free something. Or you can put another magic string that say, I want to use a Docker image. So we have to use a pipe, and then you can specify the image from Docker Hub. You can also specify images coming from a protected registry, such as Azure Container Registry, or like a private Docker Hub instance, if you have the paid plan for that one. So we want to use the latest version of Nginx, just to have something up and running. So the app service, maybe all of you know it, but perhaps there's someone who haven't used app service yet. So the app service will automatically be assigned with a public addressable host name. So it's a subdomain on azurewebsites.net. So we will end up with as_webinar_. If we stick with development, then we say development.azurewebsites.net. That will be our final host name. Then we put in https:// and then that's the address where we can later on access that Nginx web server. But yeah, it's a guessing game, right? If you use a module, you don't know internally which host name is set and so on and so forth. So there's another building block in Terraform that's called outputs. Oops, not TS, no TypeScript, really. TF. Outputs are a way that you can query resources for attribute values and, for example, use them in other script by writing them to the standard output or by reusing it in higher order projects or higher order modules. We will see that later on. But for now, we want to print it to the standard output. So let's say that's the web app URL, and that has a value that comes from Azure RM_app service. And now IntelliSense is broken again. App service, web app. And the web app has a default _site_host name. Let me quickly check. There is the app service. And again, we have an attribute reference down here, default site host name. And as you can see, you can query other things like outbound IP addresses, if source control is enabled, yes, no, with credentials for that one, and so on and so forth. But for now, let's stick with default site host name, And then that will be printed out into the terminal. But maybe you ask for credentials or for passwords, then those values should not end up being written to logs or to standard output in clear text. So you can say sensitive equals true, and then it will be masked out. So it's not it won't find its way in clear text into the standard output or any log file. That's quite. Oh, let's keep it in the source code. So you will sensitive equals true, and let's comment it in. So that's okay for now. Okay, so we have an output. I guess we can cycle back to the portal, hit refresh, and see that the resource group is gone. So let's bring up the terminal, but instead of invoking it immediately, let me quickly delete the default value for location, because that's a common scenario. You don't have a default value for that one or for any kind of variable. What happens at runtime? Well, let's say Terraform apply, because apply executes the plan anyway, so we can look at that one over there. Let's say Terraform apply. It checks your project and it will check some things. Oh, there's a mistake. Line 37. What's happening over here? Resource. Okay. Did I make a mistake over there? What does it explain? In resource web app. Web app. Okay. Web app. It is closed over there. Identity is there. App settings is there. It's closed over there. Interesting thing. Azure RM App Service. I'm misspelling Azure RM App Service Web App. Name is in double quotes. Looks good. Is it before that one? No, that's good. So it has to be there.
Maybe environment variable name contains some strange escape character.
Yes, sorry guys, it says contains only alphanumeric characters and dashes. I think the underscores are not allowed here.
No, yeah, you're right. It's dash. It's not. For the domain name, you're right. Good finding. Thanks for that one. Let's try something else. I think that's just a syntactic validation. Just wanted to verify perhaps that check something more. So let's give it a try again. Terraform apply. Interesting. Did a mistake. It's not that. So let's comment default value out, because empty string is also value, right? Let's say Terraform apply, and now it will ask at runtime for the location. Oh, do I have a state? No, I have a state. Why do I have a state? Man, location is a bad thing. I have already set an environment variable with that name. Let's say location 2. So, okay, come on, location 2. Okay. Just rename the variable because I did that demo already once with location. So let's say, okay, Now it recognizes that there's neither a default value nor a runtime value available for the location. So it asks you at runtime, hey, which location value should I use? So for example, I can say use East US, and then it will create the execution plan, and it would spin up all the resources for Azure in East US. So you can obviously use the question provided by CLI to answer to that, or you can say Terraform apply -var location 2 equals, let's say, North Europe. So that's also the way how you can specify variables. So it will end up in provision everything to North Europe, as you can see over here. And it won't ask you because you explicitly provided it. You can create a special file and call it, I don't know, webinar.tfvars. So that's a dedicated variable file that you can exclude, or that is, I think it is excluded. Oh, it's not by default, but you can, there it is. There's an example already sitting here in that comment. So you can, for example, exclude it from source control if there's sensitive information over here, but for us, we can say location 2 equals, what else we have? We have West US. Do we have West US? Yes, I think we have. Location 2. It's not accepted here. Well, it should be. Let's say no. Okay, location 2. Is it var dot? Not, as you recognize, I'm not using that syntax. Let's quickly double check that. TF var files. Haven't used them for a while. TF, not TensorFlow, Terraform variable files. Quickly check that one. TF vars, okay. Assigning the variable TF files. TF file. Looks good. TF vars. Location equals. Okay. Yeah. There we go. It's not accepted. Interesting. Var file. I think it's var file. Var file. Webinar. .tfvars. Come on. That looks better. Yeah. And then it takes West US from the var file, but let's get rid of that one. Oh, let's keep it in the repo. And last but not least, you can override, or you can specify values also using environment variables by setting TF, so the prefix is TF var underscore, then the variable name. Then we can again say West Europe. Like that. And then we say Terraform apply without any further notice of TF-vars or variables directly as argument. And then we should end up and see that Azure will spin up the resources again in West Europe. Okay, let's do that for now. Let's say, yes, that looks good. It will add 4 resources. Oh man, we're already at 120 in the session. Great. Let's double check the Azure portal. And wait some minutes for all resources to spin up. As you can see, there's what's now happening? Application insights. Yeah, yesterday it required like a minute. Last week it required like 20 seconds. Okay, ooh, there's a globally unique name is already used. Typical. Okay, so that's not that nice. Let's provide a unique name. Let's provide a unique name. There's a provider that gives you an UUID, or we can use a function that's called UUID to get a GUID. T-structuring, come on. So now it's harder to guess the actual name. So there's some ID. Okay. It's still destroying the resources. There's the resource group is still there. And so it already was in the middle of deploying things, so it has to delete those things right now. But let's give it a second. How we can use the time and start to modify our project structure a bit. So okay. So the intention is to end up, let's finish that with development with staging and with production later on. But let's test, or let's give that one try again. Let's say also auto approve over here. So we will see quickly the execution plan, but then it will automatically start and deploy. Oh no, they skipped the execution plan. Oh, that's new. Cool. Creating, come on. Still creating. Okay, so the app service plan is already there. So if we go back to resource groups, refresh once, we see that one is already there. No, not move. Oh, refresh. There's the app service plan. We see the small tux over here, so it's a Linux one. Then we wait for the apps for the application insights. Yeah, we're waiting for. Oh, application insights is also completed, so we should see application insights. And last but not least, the public accessible thing is still taking some time. But now it's finished, and you can see the web app URL is as-webinar development f something Azure website.net. I can hit command no control. In Visual Studio Code I can't. I can just in my terminal. I can copy that one and I can go to this and I get my web server up and running. So let's refresh once. Let's go to the webinar app service. Let's go to configuration, and then we should see the application insights instance being hooked up here automatically. It's OC5F something. And there we have over there OC5F something. So as you can see, it's automatically linked using the correct values that are assigned at runtime. Okay, so let's fire up Terraform destroy auto approve, because our project has finished or is finished now. And now let's go back to our README. So we have an infrastructure, and now we want to turn it into a module. Normally, what you normally do in a project, you try to slice your modules logically, right? So that you, for example, in your environment, an Azure App Service always comes with several other services and with, I don't know, those settings and those app settings and the key vault assigned to it and so on and so forth. Then you can create an app service module and reuse that in all your projects. For now, let's take the infrastructure that we have and say we have an infrastructure module. And what do we do right now? We take main, we take meter, outputs, oh, no, not all of them, that, and variables, and just drag them into infrastructure, right? Okay, so we have them. TF was, let's stick with them, the backup and the state file. So the state file, that's JSON file. Every time you write that project to the cloud, then a new version is generated in this one that's used to track the state of everything. I've unprovisioned everything right now. That's why it's empty right now. While looking at it, it just refreshed the file. So there are no resources in the cloud right now matching my project. Typically in a project, you push this state to a remote backend. So you can, for example, say there is an Azure app, there's an Azure storage account, and Terraform is able to put that state file over there automatically. And then they use active locking, so lock mechanism of Azure storage to prevent concurrent write operations on the same infrastructure. So that's also mentioned in the resources that you can dive deeper, but that's something you definitely want as soon as either two people use the same script or if there's a continuous integration system involved. Let's also kill the Terraform folder. So we end up in having, let's keep the vars over here. So we end up in having infrastructure with all the stuff we created. And then we have development. Let's create a new file there. There's main.tf. And we want to use that module. So the entire project we had up until a couple of seconds ago is now just in a subfolder, and we want to reference it. So we use module. We say that's the development environment. And that module is located at ... infrastructure. That's it. So you can load modules from local file system, from Git repositories. You can consume them via HTTP. You can consume them from the Terraform registry. So there's several places where you can pull modules from. And all variables become the inbound API of your module, and outputs become the outbound API of your module. So if we recall variables, we have location, environment name, and tags. And if we go there, location 2, yeah, environment name and tags. So let's say if our environment name is dev, location 2 is West Europe. And to be a little bit more flexible, let's remove that one. Let's say we want to differently sized app service plans. So we introduce another variable app service plan size, type equals string, default equals S1. And then we say description equals size of the app service plan. There we have S1, S2, blah, blah, blah. I don't know how many they offer right now. And then let's say ASP size for development is S1. We don't want to add custom tags. We're fine. We're good to go with the default tags. Then we take that into staging, into production. Okay, in production.main, we call it prod. we call it prod. Production, we need computing power. We say, give me S2. Staging. Staging should be similar to production. So we spend some time. We spend some money right now. And that's it. So I deleted the .terraform folder. And a folder is a project. So I have to go into the folder in terminal. Let's go there, terminal. Can we add multiple ones? Can we add 3? Is that possible? Yeah, nice. Okay, let's go into development over here. So we are in development. Let's go into staging over here. We are in staging over there. And let's go into production over here. Okay, so double check main.tf, main.tf, main.tf. Okay. Let's do Terraform init. Terraform init. Ooh. Sometimes Visual Studio fucks up the rendering a little bit. Terraform init. A little bit, okay. Fucks up a lot. And let's do in production Terraform init. Okay, so we have initialized all 3 environments now, so everything is ending up in having a Terraform. To use modules, we have to explicitly instruct Terraform to load them into the context. I have to make it a little bit. Can we switch orientation over there? Oh no, that just adds a new one. That's weird. Can I close that one? That closes all. This one. Okay. Okay, so let's give it another try. Terraform get. Ah, come on. Let's move to terminal. This is drives me crazy right now. Okay. Split vertically. Okay. D. Okay. So CD. Now we go into development over here. Then we say PWD. Then we go into CD, the same thing. Come on. Copy. Paste. Paste. Then we go over here into production. And there we go into staging. So now we should be again in the right context. Let's say Terraform get. That's what we use to load modules into the context of a project. Terraform get. Terraform get. Get. Then let's say Terraform apply. Let's see if it brings up the first plan. If it does so, then we can spin up the other ones. That looks good. Terraform apply. Yes. Terraform apply. Okay. So now we are having 3 different environments in the same context, project context, the same Visual Studio Code window. You can just have one there and assign the values at runtime. But my personal opinion about that is I want to see the infrastructure of my entire project, no matter if it's dev, test, or prod, at a single point without having the requirement to dive into environment variables or stuff like that, or values assigned in Azure DevOps at runtime. I want to see it in my Git repo at some point and see, okay, this is how development looks, this is how production looks. And all I have to do for that on a high level, from a bird's view perspective, I look into main, in development, and I see, okay, development uses S2. Okay, S1. Production uses S2. Staging uses S2. Okay, so maybe if we go to resources and all of those are deployed, they are all on their way, maybe it's a good idea to size down staging to save some money. Maybe it's a better idea to say production hot equals true. Makes sense to have that there, because then we have some Azure monitor looking at resources with a given tag. Okay, I do some changes and all deployments are good to go. I say Terraform apply on development. That should say nothing to do. We say Terraform apply on staging. That has to scale down the app service plan. And we say Terraform apply on production. That has to add some tags. And let's verify that. What? Storage account, okay. Why is development doing something? Something wrong? Oh, what did I do? Okay, some default values. Let's focus on one. Sorry, fucked up something. Web app will be replaced. Why? Because I used UUID. Makes sense. Yeah, that demo makes no sense. Let me quickly destroy everything and then I will explain why that happened. Terraform destroy autoproof. And over here also Terraform destroy autoproof. So the problem is that in our infrastructure, I hit the point that someone or somewhere on Earth is using AS-web service-development or dev already. So quick fix, I added a unique identifier. The unique identifier is unique per execution run because I just used the built-in function. There's a module that generates the UUID once during the first provisioning, and then it keeps that one. So that will be the right one. But for now, let me quickly just add something. Okay. And then we have a more consistent, or we have a stable name for the app service, and then that one should also be good to go. But go to production and remove the hot tag. Then we look at the sample just in production. Let's say Terraform apply -auto approve. Terraform apply auto approve on staging and Terraform auto apply auto approve on development. Let's resize those because we will focus on production right now. And having that being up and running in a couple of seconds, we can use the time to catch up with the slides. Yeah, the slides, I just skipped that point with authentication that I explained, that there are several ways how you can authenticate using Azure. And then it's time to move in the last demo part, quick demo, or we'll quickly show you a sample with GitHub Actions. So Terraform provides a bunch of actions as a package that you can just load into your GitHub Actions. And then you can use secrets to establish authentication mechanism to the Azure cloud. And then you can display outputs from format, validate, so Terraform format, Terraform validate, or Terraform plan as part of the pull request workflow. That also works with Azure DevOps. There are dedicated Terraform commands or actions, how they call it. So there you can just use the CLI, and the same applies for Jenkins too. So I took GitHub Actions because I think it's quite nice to have the automation directly close to the source code. But before we look into the GitHub Actions thing, let's give Azure one spin. So we have the production over here. Let's double check. Production should be in S2. Then we can check that is standard S2. Okay. Let's go to development. Should be quickly verify standard S1. That's right. Our staging or production resource group, but just have those two tags. So as a simple change, let's go there and add that hot tag again. And let's say Terraform apply. And now it looks into the cloud, and it should recognize that there is just one thing that it has to change. Everything else would be surprising right now. Come on. Yeah, there we go. 4 things will change. It will change every resource and add the hot tag on the resource group, on the application insights thing, and you get down till the tag, you get which one is changed and why it is changed. The same over here for the app service. Yeah, that looks good. Let's execute that one. Takes a second, and modifying all the things. Come on. Don't like waiting so long. Unbelievable how long it takes to just write some tags, right? So let's go to the tags view, then we should see it hot equals true, and the development one is just app and responsible. And to verify that we can see the state, that's also written down here. If we look for hot equals true, it's actively tracking all the properties of the resource so that you can see that you have that one center of gravity, which is the state. And that's why it's critical to push that state from your local machine towards a centralized thing like Azure Storage or how's it called, AWS bucket, EC3, EC2 bucket, I think it's called. So there's several options that you can push that state to a remote backend. Okay, so that's it for the Azure demo. And last demo that I already introduced was the GitHub Actions thing. GitHub.com/Thorsten Hans, and there is a TF Actions. Okay, so great. Remove the name of the repo. Okay, so there is already a repository that I've created. Also simple, just a resource group. And it has a GitHub folder, workflows folder, and a Terraform YAML. So that's just a regular GitHub Actions YAML file describing a job that will be executed on Ubuntu and several steps that happen as part of that continuous integration workflow. And as you can see, I say that those actions will use the Terraform GitHub Actions from the master branch in a Terraform action in a given version, so they are pinned. And Then I will execute Terraform init, which has to finish successfully in order to put a green check mark on that on a pull request. Terraform validate, so it has to be syntactically correct in order to be a valid format. That means it has to follow the Terraform and Golang formatting rules. Maybe you recognize that during the demo. If I am lazy and chaotic over here and arrange my code like this, and I hit save, Visual Studio Code automatically formats it. If I remove the blank line over here, then it arranges it with the other properties over there. So I have an extension installed. What's that? Extensions. What is it? Show. What's it called? Command Shift. I can't remember. Extensions. I don't know. So I have installed, how's it called? I think it's called Terraform, yeah. So that's the extension I use in order to get that IntelliSense, and I'm running it in an experimental mode, so that's why it crashed a couple of times during the demo. But that one is executed in Terraform format during saving files. So in order to get it up and running with a cloud provider like Azure, you have to authenticate it. So I created a dedicated service principal using Azure CLI. So AC, AD, SP, create for ABC, skip role assignment, like this. And then you end up in having an app ID and password and so on. And then I say AC, AD, SP role assignment. Oh, sorry, AD, SP role assignment. So you have to just give him some rights. But I have to delete that one quickly. AC, AD, SP, delete, --ID. Okay, so I end up with some metadata about its service principal. Noticeable is the ID and the password. Then you take those metadata and put that underneath settings, and that's where you can set sensitive values for actions as think of environment variables. Then you just put in name and value. And so there's the service principal ID, the secret, the Azure tenant ID, and the Azure subscription ID. So all the things that I used in my, in my Terraform workflow, right over there, where I said environment variables, and grab them from the secrets. GitHub token is set by GitHub automatically, so that's fine. So how does that look like? Let's go there. Oops. And I have somewhere I have TF actions. Let me quickly. Oh, there it is. Terraform -GitHub actions. Let's git checkout master, git checkout new branch, webinar FFM demo. I've already did that demo. So let's open that in code. And let's say, let's just add another tag, or let's add a resource, Azure RM, application insights, AI, name, AI demo, resource group name is Azure RM resource group, RG demo, name, and the same applies for location. We use location, and we don't care about tags. Don't care about tags. Name, resource group name, location, application type. Application type equals web. That's it. We check what we have done. Git diff. Okay, git add. we push that local branch to a new remote branch, webinar, FFM demo. And so we should see the new branch. Oh, it's already there. We can say create a pull request, edit application insights to our infra, create a pull request, and then asynchronously GitHub action will kick in. So it takes a second, and there we are. Let's go to details. So it takes a couple of seconds because they internally spin up a container, and then they run that story inside of a container. It looks at performance. So is the pull request following the Terraform and Golang format guidelines? Yes, it is. Otherwise, it would exit with a non-zero exit code, which would result in an error. Is it valid? Yes, the configuration is valid. Now it says Terraform plan. What happens if I execute this infrastructure or this project with the change into my Azure environment? And then you see it will create something, right? We see that over here, but we also see it over there. If we go into Add AI, and then we can see what happens, and it will add the application insights instance. And if we say, yep, we are good to go, we say merge it. And there we are. Now it is on the master branch. And then we have the main TF here, and we can immediately spot how the infrastructure for the project looks like. So that was the second demo of my of that talk about Terraform. And last but not least, in that slide deck, you will find a couple of resources that may help you when you dive deeper into Terraform. So again, all the possibilities that modules offer. There's a concept of workspaces. If you don't like that approach to have multiple environments in the code base, if you want to use like a logical context for an environment, then you should look into workspaces. Then a little bit more info about the state, about state backends. And then I've written a guide in the context of Azure on my blog, I think almost a year or a little bit more than a year ago. Then there is Terraform best practices. And there is a book that's called Terraform Up and Running. It's a little bit aged in the meantime. I don't know if it has been updated recently. And that one is focusing Terraform in the context of Amazon, of AWS. But nevertheless, I really enjoyed reading that book. That gave me a lot of insights and technical background, also background about infrastructure as code as in common. So that's definitely worth reading if you have to stay at home in the current situation. At least we in our region here in the Southwest, we have to stay a little bit longer at home in Germany. So maybe it's worth checking out that one, or there are plenty of other online resources for Terraform. So that's it from my point. I think we can move on to Q&A if there are questions. Damir, you want to?
Yes, we have collected some questions. Maybe Indranil, you can share it.
I have collected the questions. I have the file here. I'll upload this file in the chat so you can see all the questions in one place and share them.
Okay.
Yeah, let me just quickly share this file in the chat.
Yeah.
Yeah, here it is.
You have to assist me. I'm not using Teams.
Did you post the file? I still don't see it.
Hold on. It's still in the sending.
Okay, it's still uploading. Okay, because I expected it to be there somewhere in the chat. So you all see my chat right now, and
we all see your chat right now.
Okay, cool,
Yes.
cool.
Yeah, it's still in the sending. I don't know why.
But maybe as long as this sending we have few questions. And the first one, just let me take a look on that. Was question related about Terraform and capability to import existing deployment in Azure into the script.
Yeah, good
So
question.
for example, you understand you are working, playing with it. Say, oh, this is a great thing. Let's start now to do initial Terraform string, which I will then maintain a step away and so on.
Yeah, good question. So what's the story about get your, for example, ARM template or existing Azure infrastructure into Terraform? So you can use an existing ARM template as resource, as an atomic resource in Terraform. That's great to lift and shift, right? To get an existing thing into that Terraform workflow. But Terraform sees that as an atomic resource. So that's was a quick way in the early days of Terraform how to get up and running with Azure to see if the Azure ARM API is working or behaving as expected in that workflow. However, there's also a Terraform import command. But to be honest, I haven't used it in production with pre-existing infrastructures. Something else that you can do a hybrid approach, right? If you have an existing deployment in Azure, you can read information from anything in Azure using so-called data sources. Your presentation ended. Okay, great. So no worries. So we see the question. Okay. So Terraform knows the concept of so-called data sources. We used resources right now to write things, but are data sources that you can use to read, for example, connection to the existing SQL Azure that has been there and is there for years. So perhaps that's a way how you can, find a smooth transition. Okay. So can we bring up the questions again, or?
I'm just trying to get up questions. It was posted in another chat.
Damir, I sent you the file in your personal, so you can probably take it from there. All the questions are in this file.
Okay. There was maybe the second question, just a moment.
Or if not, I can also share the screen.
Yeah, that would be great.
Then I'll share the screen. Yeah.
Yeah. Okay. That's easier then.
Yeah.
Okay.
So.
Okay, is there a way to infer the code from okay, that was the one that Damir already mentioned.
Yes.
How does Terraform behave in the case there are additional manual changes on the same infrastructure? Great thing. So Terraform is able to do only that what's offered by the ARM APIs in the context of Azure. And not everything could be done using ARM. For example, think about having Azure Service Bus geo-replication. So you deploy Azure Service Bus to North Europe, to West Europe, and to want to pair them to have failover or high availability. Those geo-replications could not be set up using ARM APIs. In that case, you have to manipulate those two resources later on by using Azure CLI or a shell script or PowerShell or manually in the portal. However, what you can do, you can instruct any resource in your Terraform project that it ignores changes after it has been created. So that's exactly what this question is about. How can I prevent Terraform from, re-changing a value back because I can't set it in ARM or in Terraform? So Daniel, I think that will be the thing that you should look into. So third, are currently storing Terraform state file locally. Right. How do you handle it? Yeah, exactly. Working on a team, Peter. I answered it in the meantime. So there's a concept of state backend, and they only offer state backends that provide lock mechanisms. So they actively lock the file as soon as the first person or first CI run enters the Terraform apply stage or Terraform destroy stage, any write operation. And so no one else can bring you into concurrency issues from that point of view. Is there any advanced refactoring support? Great question. So yeah, having a good and reliable Terraform IDE is I think it's very easy, right? If you don't have a fucked up corrupt installation of VS Code like I have, because I try out all the new things every day, then that should work for you. So there is a refactor. Another tool set which is great for Terraform, all the JetBrains IDEs have built in, or there is an official module or a plugin, how they call it, for Terraform and HCL. So they are also worth checking out. And if you want to be a little bit more puristic, I was using VI up until Visual Studio Code became a thing. So there's also great VI integration. And what I know, a bunch of people from the Terraform community that are actively working on Terraform are using VI. I mean, my days in VI are gone. Yeah, Visual Studio Code or Rider or WebStorm, that's my go-to address if we're talking about IDEs. Can I code some advanced logic, some service, bus topology, create queues, forward subscriptions, topics? Okay, so Marco asked, what about, a little bit more advanced infrastructure things. For several resources, like Service Bus, for example, there are so-called, there are nested resources. For example, in Service Bus, you can describe queues that will be, or topics that will be provisioned automatically. But that also heavily depends on what Microsoft exposes in ARM APIs. Normally, Terraform is adopting changes very fast. So when Microsoft changed Azure Frontier from a local service to a global service, there was a breaking change in ARM API, and the Terraform provider was changed 2 hours after or a couple of hours after the API was changed. So that's really, really fast, because what Terraform does, they just have a tool that used the Swagger documentation from ARM API to create that provider. So you are limited to that. And if the ARM API defines it, or if the ARM API specification has the same definition of advanced logic like you have, then yes. If not, then the only chance that you have is to run a bash script right after, or PowerShell script right after the provisioning finished. And that's typically, it's not optimal, right? I get that point, but that's, I would say 70 to 80% of the projects I am involved in with Terraform, we end up to have Terraform, 90% in Terraform and a 10% Azure CLI script. That's real world experience, right? So you can't do everything in Terraform. And the same applies for Gloomy, and the same applies for all the others, because they are always talking to the APIs. Can you test any of the code when doing such setups? Yes, you can. There is an open source unit test framework for Terraform, I guess. At least I remember looking into it a couple of months ago. But don't judge me on the name and don't judge me if it's still on under active development. But what I can do, I can browse through the history of my things of my browser and try to find the thing I was looking into, and I can provide it to Damir so he can change it in the meetup group, at least the link for it. So there is a testing support for Terraform. And perhaps an interesting side note, there's also a version manager for Terraform that's called TF for Terraform, ENV for environment. That's something, if you have different projects, you definitely want to use a Terraform version manager because you should pin the versions, right? Okay, next questions. Are all Azure features available or only that one supported by the provider? What have to work around? Yeah, that's a similar direction. So yeah, you're limited to the provider. There is a dedicated provider for Azure AD. So for example, if you're looking into Active Directory related things, then there is a dedicated provider for that one. If so, is there a workaround? Yeah, of course, there's another workaround. You can use an ARM resource and provide the ARM template for the missing resource. So, yeah. Is Terraform good to manage Azure functions, or better use Terraform for stateful resources and tools like serverless framework or stateless? It's quite good for functions, because what happens technically, if you spin up a functions app, you behind the scenes, you generate an app service plan, function app, a storage account where the function state is persisted, and an application insights instance. And if you want to have more control about any of those counterparts, then something like Terraform is definitely valuable to get some insights and to, also to be able to reproduce it or to stamp out multiple copies from that infrastructure. So I think it's worth it. We use it in Azure in projects that are relying on Azure functions. So at least it is worth giving it a try. And my personal opinion is the bigger the infrastructure is, the more benefits you get from infrastructure as code overall. We tend to run infrastructure as code as part of Sprint 0, so the project initialization phase, because then it's a small peak or small workload, so like a day or 2 days, or depending on the infrastructure, right? Maybe bigger, maybe smaller. But later on, it's tough to find all the properties that were hidden behind all those checkboxes and radio buttons and so on. But it is possible. I was on a project where we added infrastructure as code with Terraform on an existing Azure infrastructure for a bigger project. It was quite challenging. It was tedious to find all those attributes and their values. But yeah, it is possible, and it's definitely worth it from my point of view. Would you prefer Azure CLI over Terraform? Good question. I love Azure CLI. So I back in those days when physical conferences were a thing, so not that far away in the past, I submitted quite a bunch of talks on Hail the Azure CLI, Dev the Azure portal. I love Azure CLI. I use it all day, but it's not infrastructure as code. And it's not, it's easy to spin up things. It's easy to play around, to look into things, to get insights, to get connection strings, IDs, whatever. But it's not good in documenting change, because it's not declarative, right? So maybe the one that is pasting his Azure CLI scripts that he used to modify the existing infrastructure to the Git repo missed just one line, and you end up and you're lost. You're lost. So I see Azure CLI on a different level.
Oh, that's totally true, Thorsten. That's totally true, because Azure CLI is a thing consistent in itself. You have a little script or whatever, and that is executed command by command. And Terraform is all script as it wants. It's scale in parallel, and you can rely on dependencies and so on. Last resource.id or something like that.
Yeah.
This is in any kind of shell scripting crazy like CLI.
I mean, I've done Azure CLI scripts for they are, I don't know, hundreds of lines long. I like it. I like the flexibility, but it's not that strict. It's not that convenient when it comes to, as Damir said, referencing things and so on and so forth, and connecting things to each other. There was another question, I guess, that there's a Terraform
questions upcoming.
Sorry?
That was the last one which I noticed, the number.
Yeah. There was a comment. There's perhaps it's interesting for other ones. There's a Terraform book coming in July this year, Terraform in Action from Manning. Yeah, good point. I like Manning's in Action series. I really like them. That's worth checking out. I also started a couple of times writing an ebook, but these days I have to. It's hard to focus on writing a book if your mind, is thinking about hopefully all the family members are safe and healthy. So that's a little bit lower priority, but maybe at some point in time I will publish something too. But Manning is definitely worth checking out. Yeah. Cool.
Okay. Thank you so much, Thorsten, for your time, for sharing this great knowledge. I hope everybody enjoyed. And you are going to provide this URL for everything what you did. Maybe that's what you have committed, what you scripted live right now. You can commit somewhere and send us URL, and we can also share that as a part of the content.
Yeah, definitely.
And we will try to prepare this recording and to finish it and also to publish it somewhere.
Yeah, I'm fine with just publishing the raw material if that's fine for you.
That's fine.
Yeah, we just have to. I think the only thing we have to, blur out the attendee names if they are not, if they haven't approved publishing it. But from my point of view, thanks for having me. It was fun. It was a pleasure to finally do a meetup again in the Frankfurt area, let's say that way, because Damir and I, we talked about doing a meetup for quite some time. And I think back in 2019, it didn't work out because of some issues with the dates and something else. So yeah, this time coronavirus.
We have been waiting on pandemic and.
Yeah. But yeah, it was, thanks for having me. And if you have any further questions, don't hesitate, just ask. I will forward the slide deck and all the sample code to Damir by tomorrow morning latest. So I can't promise if I will make it this evening. So yeah, thanks for joining and stay safe and healthy.
Thank you so much, Thorsten. Thank you everybody to joining us, and see you next time. I think in 1 or 2 weeks, we have Global Azure Bootcamp here, virtual, with great sessions, and please join us. Thank you so much. Bye.
Thank you. Bye.